In this video, you want to understand the importance of cosine rule as well as the sine rule. You must know exactly when and how to use it, right? So that is the most important thing. Now, the importance of the cosine and the sine rule and the trigonometry is that it helps us to determine the distance between two things or three things, right? So exactly, let's limit ourselves to three things. So let's say you are here, you are located at this place, and then your friends also here. So this is the college, right? So there's a college here. So mathematically, we say that since you guys are three, you guys are forming what we call a triangle. Now, the reason for using these two and a sine rule is to help us to determine what will happen if you want to know the distance from here to your friend's place. So how long are you going to take for you to reach your friend's house? Or maybe your friend is also going to your college. How long are you going to take that? Or maybe even you watching me right now, you want to move from here to your college. How long are you going to take there? So that is for the distance. What about the guy here? The guy here is what we call the angle, right? So the angle, the importance of the angle here is, let's say you are here. So how long are you going to turn before you get to your road, on your road, right? So maybe if you are here, how long are you going to turn before you get on this road to the college? So that is the importance of these two guys. So one helps us to determine the distance, the other one also helps us to determine the angle between. Right, so in this video I'm going to demonstrate that with the help of example, and know exactly when and how to use these two guys. But here in this video we are purposely going to talk about the cosine rule, and then make sure that you watch the video to the end, whereby I give you exactly how the cosine rule also looks like. Now let's have a look at this example here. Okay, from the example we are given this beautiful diagram here, right? So this is a diagram here. Of course, this is a combination of two triangle. As you can see that, so this is the first one from here to here, and then maybe from here to the other side is also another triangle. So there are two different triangles that are being combined together, right? So with that, we are also going to solve it one by one, so separately. So from the question, we are told to find the angle. So this is the notations of angle what? A, D, and then C. So what this thing means is that we want to find the angle at the middle. Always the letter at the middle is exactly where we are going to find the angle. So this is the angle that we are looking for. So A, D, and then C. So the angle here, right? So the angle here. So by my example, you consider maybe, let's say, how long this guy is going to turn before he or she gets to the road to this place. Is that okay? Or maybe how long, if you are here, how long are you going to turn before you can get to this road? That is exactly what you are looking for. So now let's see how to solve that problem, because this is two different triangle. Let's solve them one by one. So let's solve the first part. So what I mean by the first part is that, so let's say this guy is here, and then there's another guy, so A, B, and then C, right? So let's solve this triangle first. The reason is that we are only giving the outside, right? We are not giving within. The tool that can help us to solve these things, that those are the cosine and the sine rule. Is that okay? So because this is a triangle. Now one quick thing you have to understand here is that the cosine and the sine rule applies to a triangle. Very, very important. A triangle that is not a 90 degrees. What I mean by the triangle that is not a 90 degree is that look at from here to here to here, we are not seeing anything that is a 90 degrees. So the 90 degrees triangle looks like one side of the triangle is 90 degrees. So this is a right angle triangle, right? So this is a right angle triangle. It seems that one side of the triangle must be a 90 degrees. Is that okay? But the cosine and the sine rule does not apply to that type of a triangle. That is one thing you must pay attention to, right? So we use this guy and this guy when the triangle that we are dealing with, it is not a right angle triangle. Alright, so what I mean by the right angle triangle is that one side of this thing is not a 90 degrees. So assuming, let's say you are here, so let's call you B, and then we have A, and then as well as C. So from this guy to this guy is a straight. There's a straight route here, so this is a straight route, and then from that guy, the A to the B is also another straight. So they intersect here. Obviously, there's no curve and no bend. So here will form what? A 90 degrees by measurement. Is that okay? But if we want to use the sine and the cosine rule, we don't apply that to this method, and I will explain that in this video, so make sure that you stick to the video to the end here. Okay, now back to our question. Now you can see from the example clearly this sign here indicates that this side is 90 degrees. Is that okay? So this side is 90 degrees. We cannot apply that sign and the cosine rule on this triangle, just this one. That is the A, B, and the C. So what tool can we use to do this thing here? Now the tool that we are going to use is Pythagorean rule, right? So that is one thing. Why? Because this one side here is right angle triangle, right? So one side of this triangle is 90. Is that okay? So if one side of the triangle is 90, we have another tool of using that. That is what the Pythagorean theorem or the Pythagorean rule. If you don't know what the Pythagorean rule is, it says that this guy here, the longest side, obviously this triangle, so the longest side. So let's use another symbol here. So let's say this is our triangle, right? So this is our triangle. The longest side here we call it a hypotenuse. That's just a name. So if you are here, you start at this place. Here will be your opposite, right? Here will be your opposite, and then this guy will be what? Your adjacent. Is that okay? So that law says that, or that tool says that the hypotenuse here squared, right, is equal to the adjacent square plus the opposite square. So we use this guy when we are dealing with the right angle triangle, right? So one side of that triangle is 90. So I'm using that because this side is 90 degrees. Why are we using that? We have this side, we have this side. We don't know this side. Is that okay? We want to find this side so that we can easily determine what the angle here. So that is exactly what the question is asking us to find, right? So we want to use this guy here to determine, with the help of these two guys here, we can easily determine what the side here. So since we don't know here, we must look for that, and then the tool that can take us to this place is the Pythagorean theorem. So you can see that this guy here will be what our hypotenuse, right? So assuming you are here, so you are here, assuming you are here, right? You are here right now. So here will be your opposite, and then down here will be what your adjacent. If you don't know how to solve this, make sure that you just subscribe to the YouTube channel. We have a video on that. Is that okay? And now let's move on. Since you are here, so this guy will be your adjacent, this guy will be your opposite, and then the law says that the hypotenuse squared is equal to a squared plus the opposite squared. So we are just going to replace that, right? So we don't know the hypotenuse, so the hypotenuse squared here. So we have the adjacent to be 4, right? So 4, here is it, here is 4. So 4 squared plus 3 squared. So if you do this calculation, you should have something like 16 plus 9 equal to 25. So we want the hypotenuse. The hypotenuse is this line here, right? This line here. So that is exactly what you are looking for. So you need to take the square root of both sides. So after taking the square root, you should have your h to be equal to 5. So this h here is the guy here, right? So this h here is the guy here. That is 5. Okay, boom. Then we are free to go. We are free to go because we need this side. We need this side here. Now you can see that the next triangle, which is A, D, and C, there's no sign anywhere that tells us that this triangle is a right angle triangle, right? So since this guy is not a right angle triangle, we cannot apply the Pythagorean theorem. So the tool that we are going to use here is a cosine rule, right? So that's what I just said earlier on. So we are going to use the cosine rule. So let's look at how exactly the cosine rule looks like. Now let's see how the cosine rule works. So I'm just naming the distance, right? The length from here to here to be A, and then here to here to be B, and then here to here to be C. If you are not okay with the variables and numbers, don't worry. We are just using it to replace something, just like your name, right? So if you somehow call you, you must respond by image. So the person is able to identify by image. So the image that we are using here is from here to here, we are calling it A. Right, and then from here to here we are calling it B, and then from here to here. So this is what we call the cosine rule, right? Says that A squared is equal to B squared plus C squared minus 2BC, and then cause the angle here. So I was playing this. Don't let this thing scare you. So all that it means here is that if you want to determine the angle, the length here, right? So the length here, the distance from here to here. So you want to determine the distance from here to here. Is that okay? So this guy must come first, right? Pay close attention. So this guy, what you are looking for, must come first. That is what the A squared here. This is what we are looking for. It's equal to the rest of the two sides, right? So this guy and then that guy. So that is what the B squared plus the C squared. So these two guys are left out. Minus 2BC. These 2BC are just these two guys here. Can you see? So that's the way of memorizing this formula here. So you can easily remember. So these two guys here minus what 2bc. So these two guys, and then cos what? Cos of the angle that we are looking for. Cos of the angle here. Is that okay? Cos of the angle. So this is what we are looking for. And then let's say you can easily remember this thing by saying that this starts here and then this ends here, right? So whatever you used to start will be the end here. Is that okay? Don't worry, you go back to the examples and see how you can apply this. Now the second one is that if you want to know the length of this guy to this point here, right? So from here to here, we want to know the distance from here to here. This guy must come out, right? So this guy must come out. So this guy is that is the b squared here is equal to the rest of the two guys. So we are left with this guy and then this guy, right? We are left with this guy and then this guy. So that is the b squared, that is equal to a squared plus c squared minus 2ac. Have you see? So 2ac, these are the two guys here. So minus 2ac and then cos of the outside, which is the b. So the third one also goes the same thing. So we know exactly which one to use. They are all the same, but depending on exactly what we are looking for. Now let's see which one we are going to apply here. Now our triangle says that look at the triangle. So we want to find this guy. So that is what the question says. Says find the angle ADC. So this guy here, right? So this guy is exactly what we are looking for. So if this guy is what we are looking for, then this will be our length, right? So wherever you are, this guy here will be what your length. So this guy must come out. Is that okay? So what I mean by that is that if you are here, we want this guy, we want the length of what from A to D here, right? From A to, let's say A to somewhere B here. So we want this guy here. Your angle is facing you. Is that okay? So if you are here, we want this length here, this length here. This guy will be your angle, right? So that is just as I explained from the beginning. So if you are here, the length here, your angle will be the one that is outside, right? So the angle will be the one that is outside. So if you want to apply that to that, so the angle here, this angle here is outside. Can you see? This angle is facing this guy. So here your friend is what 5. So 5, if 5 comes out, so the angle is exactly what you are looking for. So what I mean by that is that here I'm going to use the letters outside. So you can see that this is AC, right? So this AC, the length here is what AC. So AC what squared, right? So AC what squared here is equal to the AD. Which one will be the AD? The rest of the two guys out here, right? So the rest of the two guys, so AD here, and that is what the 7 here, and then the CD is also what 6. So we are just going to replace it. So you may go for the AB plus or plus C, just like in this formula, right? Just like in this definition, you may go for that, provided that you know exactly what you are doing. So if you use what has been given to us, you have our AC squared is equal to AD squared here, and then plus CD squared, right? Minus 2AD, right? So 2AD, the first guy, and then multiply by the second guy, which is CD here, right? Everything cos theta, right? So the cos theta is corresponding to the one that is outside, which is the 5 here. So here the 5 squared. We know that the AC is 5 squared here. That is equal to 7 squared, and then plus 6 squared. They are all given from the question, right? So this guy is exactly, so 5 squared is equal to 7 squared, and then plus this guy, the one that is out here, 6 squared. And then multiply by what? These two guys here, right? So multiply by the 7, and then by what? By the 6 here, and then everything cos theta, right? So cos theta here. So if you do a calculation, you should have what 25 here. That is equal to 79 plus 36. So here, if you multiply these three guys here, you're going to get negative 84. So and then cos theta. Know exactly what you are looking for. Let's say you should find this angle. Is that okay? So that is what we are looking for. So all the guys are available. So if you do a calculation, you should have what negative 60 is equal to negative 84. So we want this guy. So we are going to divide this guy by what negative 84 and then negative 84. So we are dividing both sides by negative 84, right? So that we can have this guy alone. So negative 60 divided by negative 84. That gives equal to a cos theta, right? So you know how to manipulate this. So let's see how to find the angle here. So if you rearrange, you are going to have what cos theta is equal to cos theta, right? Cos theta is equal to 60 divided by 80. You may decide to reduce this guy. Is that okay? So here, remember, we are looking for the theta, right? So we are looking for the theta here. So theta, you are going to take the cos inverse of both sides. Just like in the case, if you have what 2s is equal to let's say 4, what do? You have to divide both sides by 2, divide here by 2. So we are applying the same idea here, but in trigonometry here we call it what? A cos inverse, right? So cos inverse, so that the theta can be alone. So we are having what? Theta here is equal to what? The cos inverse of whatever is here, that is 60 divided by 80, right? You may use the calculator on this if you don't know how to convert this guy here. So here I should give him what? 44.42 degrees. Is that okay? But the question says you should round that to what? To the nearest degree. So this guy will be what? 44 degrees, right? So I promise of showing you what how to apply the sine rule. Let's see that. So this is exactly how the sine rule looks like, right? So the sine rule also applies to the triangle, which in case one side is not what a right angle triangle, or one side is not what a 90 degrees. So let's say we are naming here A and then B and then C. These are just the name, right? So from here to here we are calling it A, and then from here to here we are calling it B, and then from here to here we are calling it C. So what is the sine rule saying? The sine rule says that whatever is here, you see, if you are here, this guy, you are facing this guy, so this guy will be your angle, right? So let's call that a capital A. If you are here, you are facing this guy. So if you are here, you are also facing this guy, right? And then if you are here, you are facing this guy. Can you see that? So what you are facing is your partner. So the sine rule here says that if you are facing here, so divided by also your length here, right? So this length here divided by whatever the angle may be here, right? So here is what? A over sine A. So the sine A equal to this guy. They say they are the same, right? So they must be the same. So it's equal to this guy here, and then whoever is facing. So here we will B over the sine of the angle that is facing you. So here to the same thing equal to. So these three guys are equal, right? So all that matters here, you just need to know the two sides, right? You just need to know the two sides of the triangle, then you are free to go. Or the other way around is what? We turn this guy upside down. One is used to what? Find the length, and the other one is used to find what? The angle, right? So all that matters here, you just need to know maybe 3 of them. We have a question on that. That's why I said earlier on that make sure that you subscribe to the channel and then check our videos. We have all the videos on this type of questions. So thank you for watching it.